Before artificial intelligence entered the workplace, most careers followed predictable paths. In the early 2000s, nearly 80% of global jobs were traditional roles such as manufacturing, retail, agriculture, and clerical work. Employment structures were stable and specialized. Workers trained for a single profession and often stayed in that role for decades, with limited need to continuously update technical skills. Recruitment before the AI era relied heavily on manual processes. Human recruiters screened thousands of resumes by hand, often spending only 6 to 8 seconds reviewing each one. According to several HR studies in the 2010s, over 75% of resumes were rejected before any interview occurred, simply because recruiters lacked time to carefully evaluate every candidate. Corporate productivity depended mainly on human labor and basic software tools. Data analysis was slower and required teams of analysts working with spreadsheets or databases. Tasks like market research, report writing, and customer analysis often took weeks. Businesses needed large teams because automation tools were limited and machine learning systems were still experimental. Education systems reflected this slower technological environment. Universities prepared students for stable professions such as accounting, law, medicine, and engineering. In 2010, fewer than 5% of global university programs included artificial intelligence courses. Most graduates entered industries that expected decades of consistent, routine work patterns. Even in technology companies, automation remained relatively narrow. Software engineers built programs that followed fixed instructions. Unlike modern AI systems, these programs could not generate content, write reports, or design products. Creativity, strategy, and problem-solving were considered uniquely human capabilities within professional environments. The global workforce was also geographically stable. Many companies hired employees locally because digital collaboration tools were limited. Remote work was rare. Before 2019, only about 7% of employees worldwide worked primarily from home. Most office jobs required physical presence and centralized workplace environments. Businesses made decisions based largely on historical data and human judgment. Predictive analytics existed but required specialized teams of statisticians and data scientists. As a result, many organizations lacked the ability to quickly process massive datasets or identify patterns that modern AI systems detect within seconds. Creative industries also operated differently. Designers, writers, and editors produced content entirely by hand using traditional tools. Marketing campaigns required large creative teams and long production timelines. For example, creating a television advertisement often required weeks of scripting, filming, editing, and post-production work. Customer service relied almost completely on human representatives. Call centers employed millions of workers answering repetitive questions and solving simple issues. Before advanced chatbots appeared, companies needed large support teams to handle basic customer inquiries such as order tracking, account questions, and technical troubleshooting. Overall, the pre-AI job market emphasized stability rather than adaptability. Workers were trained for specific roles and companies expected long-term specialization. However, the rapid growth of machine learning and generative AI technologies after 2020 began transforming this landscape, introducing entirely new types of work that had never existed before. The modern AI transformation accelerated after 2020 as computing power, cloud infrastructure, and massive datasets became widely available. By 2023, artificial intelligence investment worldwide exceeded $150 billion annually. Technology companies began integrating machine learning systems into nearly every digital product, from search engines to business software platforms. Generative AI became one of the most disruptive innovations. Unlike earlier automation tools, these systems could generate text, images, code, and even videos. This capability expanded AI from a background technology into a visible productivity tool used directly by professionals in writing, marketing, research, design, and software development. Large language models changed how people interact with computers. Instead of writing complex commands or code, Users could simply describe tasks in natural language. This dramatically lowered the barrier to using advanced software tools, allowing individuals without technical training to automate tasks that previously required programmers or analysts. Corporate adoption of AI accelerated quickly. Surveys in 2024 showed that more than 60% of large companies were actively integrating AI tools into daily operations. Businesses began using machine learning for customer analysis, fraud detection, product recommendations, logistics optimization, and predictive maintenance across multiple industries. Productivity gains from AI became measurable. Some workplace studies reported that employees using generative AI tools completed writing tasks up to 40% faster. Customer service systems assisted by AI could resolve inquiries more quickly by automatically retrieving relevant information from internal knowledge bases. Governments also began investing heavily in artificial intelligence infrastructure. Nations recognized AI as a strategic technology capable of influencing economic growth and national competitiveness. Large public investments were directed toward research laboratories, semiconductor manufacturing, and national AI training programs. The expansion of AI created strong demand for new types of technical expertise. Companies required specialists who could train models, evaluate outputs, and design AI systems responsibly. Traditional job descriptions no longer matched the evolving skills required in modern digital workplaces. Technology platforms began building ecosystems around AI development. Cloud providers offered machine learning tools that allowed businesses to create customized AI solutions without building complex infrastructure from scratch. This accessibility accelerated adoption among startups, small companies, and independent developers. As AI capabilities expanded, industries beyond technology began experimenting with automation. Healthcare used AI for medical imaging analysis, finance applied it to risk modeling, and agriculture used machine learning to optimize crop yields. Artificial intelligence started influencing nearly every sector of the global economy. This rapid technological expansion created a paradox. While some tasks were automated, entirely new professional roles began emerging. These roles focused on building, managing, and supervising AI systems, marking the beginning of a new category of employment within the global workforce. One of the earliest new roles created by generative AI was the prompt engineer. This profession focuses on designing precise instructions that guide AI models to produce accurate outputs. Businesses discovered that carefully structured prompts could dramatically improve the quality of AI-generated content, code, and research summaries. AI trainers became another essential profession. These specialists review AI outputs and provide feedback to improve system performance. Training data, human evaluation, and continuous corrections help models learn better responses. Many AI companies employ large teams dedicated to refining model behavior through human feedback loops. Synthetic data engineers represent another emerging job category. These professionals generate artificial datasets that simulate real-world information. Synthetic data helps train machine learning models when real data is scarce, sensitive, or restricted by privacy regulations, allowing companies to continue developing advanced AI systems safely. AI ethics specialists are increasingly important as organizations deploy powerful algorithms. Their responsibility is to analyze potential bias, fairness issues, and social risks associated with automated decisions. Governments and corporations rely on these experts to ensure responsible and transparent use of artificial intelligence technologies. AI product managers coordinate the development of intelligent systems within companies. They translate business objectives into technical requirements, working closely with engineers, designers, and researchers. Their role ensures that AI tools solve real problems while aligning with organizational strategy and user needs. Machine learning operations engineers, often called MLOps specialists, maintain the infrastructure that supports AI models in production environments. They monitor performance, update models with new data, and ensure systems remain stable, secure, and efficient after deployment within real business applications. AI workflow designers focus on integrating multiple AI tools into automated processes. For example, they might connect text generation systems, data analysis models, and scheduling software into a single automated pipeline that performs complex business operations without constant human supervision. AI safety researchers represent another growing field. Their work involves identifying potential risks associated with powerful machine learning systems and developing safeguards. As AI models become more capable, ensuring safe operation becomes a priority for technology companies and governments worldwide. Creative professionals are also evolving into AI-assisted roles. Designers now collaborate with generative systems to produce visual concepts faster, while writers use AI tools to generate outlines or drafts. These hybrid roles combine human creativity with machine-assisted productivity. According to several global labor forecasts, millions of new roles related to AI development, deployment, and oversight may appear during the next decade. While some traditional tasks disappear, the demand for professionals who understand and manage intelligent systems continues to expand. The future workforce will likely operate alongside intelligent systems rather than compete directly with them. Many analysts predict that most professionals will use AI assistants to automate routine tasks, allowing humans to focus more on strategy, creativity, and decision-making responsibilities within organizations. Economic projections suggest artificial intelligence could contribute trillions of dollars to global productivity over the next decade. As companies adopt automation technologies, new industries and services may emerge around AI training, maintenance, governance, and digital infrastructure management. Education systems are beginning to adapt to this transformation. Universities are expanding programs in artificial intelligence, data science, and machine learning. In addition, many institutions now teach interdisciplinary courses that combine technology skills with business, ethics, and policy analysis. Continuous learning will become essential for career stability. Unlike earlier generations that mastered a single profession, modern workers may need to update skills regularly as technology evolves. Online learning platforms and professional certification programs are expanding rapidly to meet this demand. AI collaboration tools will likely redefine workplace productivity. Instead of replacing employees entirely, intelligent assistants may help professionals generate reports, analyze data, create presentations, and conduct research much faster than traditional manual methods allowed. Entrepreneurship may also expand as AI tools reduce barriers to starting new businesses. Individuals can use automation to handle marketing, customer service, and product design tasks, enabling small teams or even solo founders to build scalable digital companies. Global employment patterns may shift toward more remote and distributed work models. Because AI tools operate through cloud platforms, professionals can collaborate with intelligent systems from anywhere with internet access, reducing the need for centralized physical workplaces. Regulation and governance will become increasingly important. Governments are already developing policies to address issues such as data privacy, algorithmic bias, and AI accountability. New professional roles will likely emerge to ensure compliance with these evolving legal frameworks. Despite concerns about automation, historical patterns suggest that technological revolutions often create more opportunities than they eliminate. The transition from industrial machinery to digital computing generated entirely new industries, and artificial intelligence may follow a similar trajectory. Ultimately, the future of work may depend on how effectively humans learn to collaborate with intelligent machines. Those who understand AI tools, adapt to changing technologies, and develop complementary skills may benefit from a new generation of careers that did not exist only a few years ago. Artificial intelligence is not simply replacing jobs. It is reshaping how work exists. Every major technological shift in history has created uncertainty at first, yet it also opened new industries and professions. The same transformation is unfolding now. The people who learn how to work with AI systems will likely define the next generation of careers, innovation, and economic growth across the global digital economy. If you want to understand the technologies shaping the future of work, business, and global competition, follow the conversations here. Subscribe to Best AI Today for deeper explanations of artificial intelligence, emerging technologies, and the trends that will influence the next decade.